Okay guys, this is page 337. I'm going to go through and show you how to solve these. And you should have already solved them, and if you were stuck, then here's a great chance to kind of see how else to think about them. This is also a great opportunity to make sure that your answers are right, and if they're not, then to see how you could solve them and then rework yours, okay? So many ways of using this. Let's look at this first one. Number one, a game board measures 9.5 inches by 11 3/4 inches. Estimate, keyword here, estimate the area of the game board. Well, we know that area of a rectangle is length times width. So we know that if there was this game board, this dimension is 11 3/4, and this one over here is 9.5, length, width. But we want to estimate, so we want to estimate to the nearest whole number. Well, that 11 3/4 is closest to 12, and 9.5 is closest to 10. And to find the area is 120 inches squared. This is all about estimating, and it looks like it might have flown off the screen, so let me back up some. Which means you're rounding to the nearest whole number in this case. Number two, in a 2-week period, 3/7 of the days. Nope, in a 2-week period it was sunny 3/7 of the days. How many days were sunny? Well, here we have this 3/7 of, and so you want a part of something. So we know that we want 3/7 of something, but how many days was it? Well, here it says a 2-week period, and a lot of you guys are saying, well, it's 3/7 of 2, but it's not 3/7 of 2. It's 3/7 of the days in 2 weeks. So you have to be really careful with your units. And so here we see we can cross cancel. 3 times 2 is 6 over 1, which is 6 days. Of is kind of the key word there, and conceptually seeing that it's a part of something is multiplication. 7/8 of the students, look at that, in Mr. Kringle's class watched television last night. So we know that we have 7/8 of something. The table lists the fraction of those students that watched each type of show. What fraction of the entire class watched the reality show? So we know that the class, that 7/8 of the class watched something, but now we actually want a part of a part, and so 1/2 of his class watched the reality show. And so this is where you really have to wrap your head around it. We know that 1/2 of 7/8 watched the reality show, and so that would give us 1 times 7 is 7, 2 times 8 is 16, so 7/16 of the class. Let's look at number 4. Number 4 says Nathan deposited 7/9 of his allowance. Oh, that's a part of something. Into his saving account. He spent the remaining amount, or $250. How much did Nathan deposit into his savings account? So this one's a little different. Let me think for a second. So I'm going to draw a picture. Okay, because I'm already a little bit stuck. So we know we have ninths. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we know that he spent 7/9. He deposited 7/9 into his account. He spent the remaining on, or $250. So what's remaining? This is remaining right here. And we know that that equals $2.50. So you begin to see how my picture is helping me, how my sketch is helping. All right, so, well, can I find out what each one of those is? Yeah, there's 2 of them, so if I divide that by 2, I know that each one is $1.25. So then how much did he deposit? Well, he deposited 7/9 of his allowance. So there's a few ways of doing this. So I think I'm going to do it, I'm going to find out how much it all was worth. So if 1 is 125, then I know that 9 would be 9 times 125, so let's find that out. 45, 4, 18, 22, 2, Oh, this is going to be hard. 9, 11. So 1125 is how much he had originally. So I'm going to take 1125. I'm going to change that into a fraction because that's what we're working with. 11 and 1/4. And I know that he deposited 7/9 of his allowance. And what I did is I just calculated all of his allowance by finding out how much one part of it was, or 1/9, multiplying that by 9 to get all of it. And then I made that into a fraction, and now I want 7/9 of 11 and 1/4. And what is 7/9 of 11 and 1/4? It is $8. It's actually 8 3/4, or $8.75. Wow. So we're kind of using everything we've learned, to be honest with you, from the beginning of the year, going between decimals and fractions, drawing out a sketch. But that is one way to solve it. Is that the only way? No. There's multiple ways to solve that, but that is how I thought about it. And the point is we want you to understand it. Here's what's interesting about this problem. They want 7/9 of his allowance, but they don't tell you all the allowance, and so that becomes the obstacle. That's what makes this hard. All of these, see here, 3/7 of the days. Do they tell you the days? Yeah, it's 14. Here it was 1/2 of 7/8. See, they gave you the information up front. Here, they never gave you the total allowance. You had to take this part and then figure it out. That's what makes that kind of tough. Let's move this one up. There we go. A little bit higher, a little bit higher. Yes. Now I want to fit it all in. Perfect. All right. Number 5. I have about 9 minutes left. 8. It's recommended that 3/5 of the calories a person consumes come from carbohydrates. If 1/12 of those calories should be fiber, what fraction of the total calories should come from fiber? So my total amount is 3/5, but I only want 1/12 of that. So that's 1/12 of 3/5. So that equals 3, I believe 3/60ths, which is 1/20th. Is that right? Yes. Calories. I need to write my units. A pancake recipe calls for 2 2 2/3 cups of flour. If Vonetta wants to make 1.5 times that, do you guys see that? She doesn't just want 1 times it. She doesn't want 2 times it, 3 times it. She wants 1.5 times. How much flour does she need? This is a straight multiplication. They want 1.5 times 2 2/3. And as you know, we do not multiply mixed numbers, we multiply in proper fractions. So 1 times 2 is 2, plus 1 is 3/2 times 6/8. And what does that give us? That gives us 4 cups. But the key word here is times, really. They're telling you times. Now, if it said as many times more, you know that means something else. But that's not what it said, though. Let's go here. The largest telescope in the world is powerful enough to identify a penny 5 miles away. How many yards is that? Well, this is a conversion problem. And so we need to be able to, we're in miles. We know that there is 3 feet in a yard. And now we need to find out how many feet are in a mile. Now what's nice is if you go to the back of your textbook, usually there's always a conversion chart back there. So I'm going to the back of mine because I don't have mine memorized. And just so you know, this is actually something we're going to start memorizing when you return. And it says here that 1 mile, where are you, mile? It disappeared. Why can't I find this? 1 mile is 5,280 feet. So 1 mile, so we would need to multiply that by 5 miles and then divide it by 3 feet to get the yards, which is, yikes, 8,800 yards is my answer. All right, feet in miles times 5 miles, divide that by 3. Why? Because there's 3 feet in every yard. Next. Each homeroom in Reed Urban Middle School receives 1/12 plot of land shown. How many homerooms received a plot of land? So here's the land, and I have 5/6 of an acre. Okay, and what we want to do is we want to know, we're giving these out to classrooms, but each classroom can only get 1/12 of an acre. And so, you know, what's really interesting is one kid in class did this. They said, well, I'm going to make this 12th. So they made that into 10/12. And what's interesting is that when you do that, you can see, well, there's 10 1/12 in this amount. That would be one way of doing it. But the thing I really want you to see too is that we want to know how many 12ths are in 5/6. Well, that's a division problem. That's 5/6 divided by 1/12. And as you know, we never divide fractions. We multiply by their reciprocal, and look what happens. We get 10 over 1, or 10 plots, which it was exactly what we showed earlier. Let's take a look at number 9. To make 4.5 gallons of ice cream, it takes 6 3/10 gallons of milk. How many gallons of milk does it take to make 1 gallon of ice cream? To be honest with you, I am 43 years old. I've been teaching for 16 years. I have a college degree. I just read that, and basically all I read is blah, 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 blah. Why? Because it's just a lot of information, so I need to read it again. And this is just an encouragement to you. You need to read word problems multiple times. Draw sketches. It helps. Let's try this again. To make 4.5 gallons of ice cream, it takes 6 3/10 gallons of milk. Okay? How many gallons of milk does it take to make 1 gallon of ice cream? So here's what it's saying. It's saying that we have to make 4.5, for every 4.5 gallons. Uh-oh, I'm not on the screen. Get back on the screen. Uh-oh. I'm going to try to hold it. We can look at this as a ratio, actually. Watch this. This is interesting. To make 4.5 gallons of ice cream, here it is, I need 6 3/10 gallons of milk. So for every 4.5, I need 6 3/10. How many gallons of milk does it take to make 1 gallon of ice cream? So here's my ratio, but to set it up as a division problem, it would actually be 6 3/10 divided by 4.5. Why? Because I'm trying to find out how many gallons of milk. Let me make sure I don't do this backwards. How many gallons of milk does it take to make 1 gallon of ice cream? And so I would divide 6 3/10 by 4 1/2, which would give me 1 2/5 gallons. Now let's make sure I didn't word this oddly for you. Here is my ice cream. Here's my milk. How many gallons of milk does it take to make a gallon of ice cream? And so I would need, how many gallons of milk? Yes, and I would get 1 2/5 gallons. That is, I think I'm just throwing around too much cream and milk and butter, and it's, man, that can get confusing. Thank you, and I will work on my next video.